Now we're going to learn how to multiply a binomial times a binomial. Our essential question is, how do we multiply polynomials? Taking a look at our first example and keeping in mind those power rules, basically what we're going to do is distribute twice. We take the first term and distribute it to both pieces in the second set of parentheses. 3 times 2 gives us 6, and w to the fifth times w squared means we have 7 w's being multiplied all together. 3 times 8 is 24 times w to the fifth. Then we distribute the second piece to both terms in the second set of parentheses. Notice that this is a -6, so we need to keep track of that negative sign as we multiply. -6 times 2 gives me -12 times w squared, and -6 times 8 gives me -48. Then we will look for any like terms that we might need to combine after we multiply. In this case, all of our w's have different powers, so we don't have any like terms. We also need to check that it's in standard form. Notice the power on the first term is the highest and it goes down from there, so this is also in standard form. Our second example, I'm going to start by distributing my 7k. 7 times 5 is 35. 7 times negative is -7. K times k cubed gives me k to the fourth. Then I'll distribute my 4. 4 times 5 is 20. And 4 times -k cubed is -4k cubed. We still don't have any like terms, however, our answer is not in standard form. The term with the highest power is my k to the fourth. Notice that the sign on the 7 is negative. That negative sign needs to go with when we reorganize our terms. The next highest power is a -4k cubed plus 35k. And finally, the term with no variable plus 20. Now we're going to look at some special products. The first type of special product are called conjugates. That's when what's in parentheses look the same, except for one of them has a negative sign instead of a positive sign. The way that we multiply these together is exactly the same, so I'm going to distribute my m. M times m is m squared. M times -3 is -3m. M times +3 is +3m. And 3 times -3 gives me a -9. This time I do have like terms after I distribute it. I have my -3m and +3m in the middle there, and they cancel each other out because they have opposite signs. So I'm left with m squared minus 9 for my final answer. We'll take a look at one more set of conjugates. Distributing my 2g, 2 times 2 gives me 4. G times g gives me g squared. 2g times 7, 2 times 7 gives me 14g. -7 times 2g, -7 times 2 gives me a -14g. And -7 times +7 gives me a -49. Again, I have like terms on this one. Notice how they are the same, but opposites, just like the two binomials that we multiplied in the first place. So they are going to cancel again, and I get 4g squared minus 49. When you multiply conjugates, you will always get two like terms that are the same but opposite, and they should cancel. Our last set of special products is squaring a binomial. When you see a binomial squared, you need to think about, what does it mean to square something? And it means multiply it by itself. A lot of students get very tempted to just distribute the square to both terms and get a squared plus 9 squared, or a squared plus 81. But when we multiply it by itself, see what happens. So we're going to get something a little bit different. A times a gives me a squared. A times 9 gives me a positive 9a. 9 times a gives me another positive 9a. And 9 times 9 gives me 81. So we did get the a squared and we did get the 81, but we also got these two like terms in the middle that do not cancel. When we combine those, we get 18a. It's very important that when you see a square, you think about multiplying it by itself and not distributive property. Let's take a look at one more example. Again, we are squaring, so I'm going to write it out twice to multiply it by itself. Distributing my 4. 4 times 4 gives me 16. 4 times negative g gives me a negative 4g. Negative g times 4 gives me a negative 4g. And negative g times negative g gives me a positive. The negative times negative will cancel. G times g gives me a g squared. Again, I have like terms that did not cancel. And to write this in standard form, I'm going to start with my g squared. Negative 4g plus negative 4g is a negative 8g. And finally, my term with no variable, plus 16. And finally, we have an error analysis. I'm going to distribute my 9g to both terms. 9 times 3 gives me 27g. 9 times negative 4 gives me a negative 36g squared. Distributing my 1. 1 times 3 gives me 3. And 1 times negative 4 gives me a negative 4g. Writing this in standard form, I'm going to start with my negative 36g squared. I've got like terms, 27g minus 4g gives me a positive 23g, and then my term without a variable, plus 3. Find the error, and we'll start class with a discussion.